Letting x and y be i.i.d exponential with lambda 1 parameter, and then we are setting L as x minus y. Then the Laplace distribution we're given has the following PDF for all real x. We're going to use the MGFs of this versus just that to show that the distribution of L is Laplace. Okay, so let's start with the calculating the MGF of L, and then our strategy is to compare it with the MGF of the Laplace and make sure that they look identical. So the MGF of L, by definition, is the expectation over e to the t L, and L is by definition e to the t x minus y. Now, because x and y are i.i.d, and can just use the laws of exponents to separate out this expression as two expectations, e to the t x times e to the expectation of e to the t. This is a minus y. Okay, let's now calculate each of these, and we know how to do the calculate the MGFs of x and y. So from now on, this is purely algebra. So this piece, let's start with it. Right, this is just, let's actually just copy this to make it very clear what we're doing here. Right, so we don't lose track of anything. And this is now the integral going from minus infinity to infinity of e to the t x, and the PDF of the exponent is of the exponential is e to the minus x, right? Because lambda is 1, so that disappears. And so this now we can write it out. Actually, the exponential here goes from 0. My bad. Like this. And so what we end up with is, right, so the support is from 0 to infinity, and then we use e to the minus x plus tx, and now we factor out the x's, right? And then what does that give us? That gives us e minus x plus, well, 1, and then minus t, okay, over dx. And this integral, when evaluated, is just e minus x 1 minus t. divided by 1 minus t negative from 0 to infinity. Okay, and that is 1 minus t, and we take the limit from x moving to infinity of e minus x 1 to that, and then limit x moves to infinity. I like to write it out like this to see exactly what I am doing this stage. Here we see that this limit goes to 0 because we're dividing by exponent, and this one goes towards 0 here, and that whole thing becomes 0. So e to 0 is just 1. So we end up having 0 minus 1, and that whole thing now becomes, we end up having minus 1 multiplied by minus this minus expression, which ends up being 1 minus t. Okay, now we do the same thing. So this is 1 minus t. Calculating this, we end up with a similar expression, but in the reverse. So this now is, I like to do it again just to be sure that I'm following in each step and not making some simple mistake. And now by Lotus we can take the PDF of y, and so that now becomes the y here, same procedure, e to the so this will be minus y minus t. So let's see, this will be minus t, so this is, keep it, so that will be t minus, and that is a minus again, so this will be t minus 1. Right, so t should be a minus there, minus, so many minuses now, 1, like this, right? Multiply in, right, yep, looks good. And this, similarly, it's just e to the minus 1 plus t minus 1 plus t and this thing now with the same logic ends up also having a 0 and a minus 1, so this whole thing ends up being 1 plus t, right? So jumping back up here, we know that this is 1 minus t, the first expression, the second one is 1, like that, and this whole thing now becomes 1, right? So let's see what, so if you just multiply 1 minus t, just to not skip this step, I think it's good to do it like that, and this whole thing now becomes 1 minus t squared, like that. All right, so this is our expression. Now let's check if we do the MGF of the Laplace, if we end up having the same expression. So what's the MGF? Well, so here we start with let's call this random variable W. So let's say W is letting W being Laplace. Okay. Now the MGF of W, by definition, is the expected value over e to the t W, and this is now the integral from let's check the support. Well, it's defined for all real values. It's all real values, so it goes from minus infinity to infinity. This is e to the t W, and now we are using the PDF, so we're not using Lotus, the PDF of Laplace, which is this one here. It's half times e to the minus absolute value of x. All right. Well, we just named it W, so it should be W here. Doesn't really matter. That's it. W. All right. So this looks a little messy, and what we can start doing is doing exactly what we did, and what we do when we have absolute values is to separate them out into the two areas, so we can handle them separately and then add them up. So let's start by moving out this half here. We're going to move now from, so for negative values, negative up to 0, we have e to the t W e, and then we have the minus there, but this inner thing should be now minus, because we're turning all minus values to positives, but then this negative just follows along. And then we're adding it up with integral of the rest of the support, and that ends up being e to the t W e to the positive, right? Positive. We have a negative here, so that's how it looks like. So now we just handled that little absolute value. Those are always a little tricky, or they can be. And what we're going to do here next is we add up these exponents into the same exponent values, and then we're going to evaluate that and those expressions separately. So okay, so this is e to the, so this is plus W now, and there's a plus TW, okay, and that goes from minus to 0 like that, and this thing here is just W and 1 plus T. Look, now it's starting to look like the expressions we had up here, right? Where there are these 1 minus T, and there's this 1 plus T. Okay, starting to transform into to what we're supposed to show. 0. Here we have e to the minus w, and we have in here we have plus t, so that's minus t 1 like that. Okay. All right. Now we start evaluating these integrals. So this is now half. We are having e to the w 1 plus t. This goes from minus to plus 1 plus t. All right. And then we have plus. All right. I'm going to just do this half up here. Just multiply in this half. E to the minus w 1 minus t, and then we have a minus sign here, minus sign 1 minus t up to infinity. All right, so we're getting there. So this is a half, and now let's write this out again, just to be absolutely clear what we're doing. So this limit here over w goes to 0 first. E to the w. We forgot this 1 plus t. And where are we now? We are right, 1 plus t, and then minus this limit that now goes to w is going to minus infinity, e to the w 1 plus t. All right, let's there's a plus here, so let's just evaluate this first, and then we do that. We see that when w goes to 0, this expression here becomes 1, and now this w value is going towards should be an arrow here that I forgot, so it's going towards minus infinity. So this thing in here now evaluates to 0. It's going towards 0, so this is 0, and so this whole thing becomes now 1 plus t, and then there is a half here. Okay, let's do this other expression here. This becomes now so there's a plus, but actually it turns into a minus, but let's just keep it there and see if it cancels out. There's a minus 1, this minus 1 here, half 1 minus t, and we're doing the same thing with limit over now we're going from w is going towards infinity in the expression of e minus w 1 minus t, and then minus the limit again, w goes towards 0, and that is minus w 1 minus t, we see that this expression here is 0. This expression here is 1. So we end up having half 1 plus t. All right, so we have a minus 1 from here, and that cancels this out. So we end up having half 1 minus c. Okay. All right, we're getting there. This was a long calculation, but we're carefully moving forward to ensure that we're not making any strange, unnecessary mistakes. So this thing now, let me just move this half out again, just to make it a little clear, and then we're going to write this whole thing on the same denominator. So we're going to take here we're going to take going to multiply by 1 minus t, and then therefore 1 minus t, and here we're going to multiply by 1 plus t, and so 1 plus t, and so we end up having 1 plus plus t, like that, 1 minus t, and then here we end up just having, going to open up this parentheses, minus t plus 1 plus t, like this. All right, so now we get the t's here cancel. 1 plus 1, that's 2, going to cancel with this half here. And this thing ends up being exactly the calculation we did here. So this is just 1 minus t squared, which is, as I just showed you, but I'm just going to copy this to make sure that we're getting the whole thing. Compared properly. So this is now true. The Laplace MGF, so L is indeed a Laplace random variable.